Okay, welcome back. Algebra 1, Section 7.3, Rational Exponents. And we're going to actually do these in two separate sections, 7.3a and 7.3b. So this first one, we're just going to talk about what rational exponents are. We're going to rewrite them and evaluate them and solve problems that involve those. So an exponent that is a fraction is a rational exponent. So you got a power, you got a base number, and the power is actually a fraction. So you might see in a couple different ways. One would be like using a variable x to the 2/3 power, or you could actually see a number as a base with 100 to the 1/2 power as well. Okay, so a couple different ways to write that. All right, so let's get to the major stuff here, and we're going to kind of write about it and give you some examples. The first one we're going to go down the second box here with the nth root, Okay, and basically what this says here is if a to the nth power equals b, then the nth root of b equals a. So it's kind of confusing when you just look at it like that. But when you put numbers in there, it kind of helps you out a little bit. So if we were to say if 2 to the 3rd power equals 8, then the cubed root of 8 would equal 2. So all that's saying is basically the power, the 3 here, is actually goes into where the root symbol is down here on the radical, and then the 8, which was your answer for the first part of the if, becomes the 8th root, and then you've got equal to 2. So you can see how they are a little changed to just kind of bouncing from one way to the other. So you can kind of go from powers to roots back and forth if you kind of get that idea. Because remember what 8 is saying is 2 times 2 times 2 equals 8. And over here you're saying, hey, what times itself 3 times? What times itself 3 times gives us 8? And that gives us 2. So it's kind of the opposite. You can see that roots are the opposite of exponents. Okay, so let's go back up to the top, kind of went in a little different order here. So b to the 1/2 power. So anything that says b to the 1/2 is saying the square root of b. So you've got your 2 in the fraction here. That's saying that's going to be the square root of b. So an example of that would be, we mentioned that 100 to the 1/2 power. That would be equal to the square root of 100. Now we don't have to put the 2 in there because that's assumed that there's no number in there. It's a 2. And the square root of 100 we know would be equal to 10. Let's say we used, and then the opposite way of writing that would be if you were given the square root of 15, you could rewrite that 15 to the 1/2 power. So they go back and forth from root to exponent. Okay, so now let's go down to the 1 over n power. So we're going to kind of combine these two, 1 over the nth power. So what this basically says is b to the 1 over n power is equivalent to the nth root of b. So whatever the number is in your denominator of that fraction goes in the radical symbol and becomes your root of the base number. So our examples here would be if you had, say, 8 to the 1/3 power. Rewrite that so it looks like it's up here. 8 to the 1/3 power. Okay, so that would be saying the cubed root. So that 3 would go in here, just like the 2 did with the square root. Now it's 1/3, so the 3 would go there of 8 equals 2, because 2 times 2 times 2, 3 times equals 8. And the other way to write that would be if we said, let's do 32 to the 1/5 power. Okay, well that's, we're going to take this 5, and we're going to put that in the radical. The 5th root of 32 equals 2. Because if I were to multiply 2 by itself 5 times, 2 times 2 times 2 times 2 times 2, I would get 32. Okay? So it's just about finding the right number, where to place it, and where it goes. In this case, it's the denominator becomes your number that's in the radical there. All right, the last one, b to the m over n power. So this one gets a little bit tricky, but I think if you just keep your numerators and denominators separate, you'll be fine. So this one we can write two different ways. If you have b to the m over n power, then you could equal, and the big thing to notice is that these are not, neither of these are 1, where we had 1 here. For that one, neither of these are going to be 1. So b to the m to the n power, you could write it the nth root of b to the m power, or you could write it as the nth root of b, and then take that whole thing to the m power. So all you're really going to do is you're just taking out this n here. You're going to pull that out, and you're going to plug it in to the radical there. Okay? And then your m, you could either leave it as a power right here, or you could take it and put it in parentheses and put it out here. It does not really matter where you put it. But notice that the b value, your base number, is with that m no matter what, comes with the numerator of that. So a little bit tricky, but let's take a look at an example, and then we'll be able to kind of show you. All right, so let's say we used 8 to the 2/3 power. So 8 to the 2/3. All right, so we use 8 to the 2/3. We're basically going to take that 3 here, and we're going to pull that out. And so now it's going to be, and that goes in the radical, so it's going to be the 3rd root, or the cubed root, they would call it, cubed root, the 3rd root. And then that 8's going to stay the same, so we could write it 2 different ways. I could write it 8 to the 2nd power, because that 2 stays there. Okay, or I could write it, if I wanted to do it the other way, I could write it, and just put in parentheses here, because we know we're squaring the whole thing, the cubed root of 8, all in parentheses, squared. So it doesn't matter where you put that 2. Really just use the easiest way, whatever way is easier for you, and you'll see what we mean. In this case, they're both pretty much the same. But if we were to solve these, this first one, what we would do is we'd say, well, this would be equal to the cube root of 64, because 8 squared is 64. And then you have to start thinking about, well, what times what equals 64? And in this case, it would be 4, because 4 times 4 times 4 equals 64. So our answer here, we could simplify, evaluate that to 4. Same thing with the bottom one here, the way that is, and this one might be easier. If you know from our above example here, we know that the cube root of 8 is 2. And then if we square that 2, we'd get 4. So in this case, the second version was probably the easiest way to go about it. Okay? Either way, we got the same answer. All right, so that's the main stuff. Let's do some practice problems here. This one, it says write each expression in radical form, and then write each radical in exponential form. So we're just kind of bouncing back between exponents and radicals, roots and exponents, and go from there. Notice it does not say evaluate, so we're not going to be evaluating anything. Even though I know they're pretty easy to, we're not going to do it. So this one, we know 36 to the 1/2 power. We should all know that's just the square root of 36. Okay? And I'm not looking for you to evaluate here. It doesn't say evaluate. I know you could punch that in and get 6. That's not what I'm looking for. I'm just looking even for it to write it in radical form. Okay? And now here, this is the backwards version. We're going, again, in radical form. But the big thing here is look at number 2. Tricky thing is how it's written. Is the whole thing going to the 1/2 power, or is it just the x? So I want you to take a look at the difference between number 2 and number 3. Number 3 is in parentheses. So that means that everything in here is going to the 1/2 power, where just here, there's no parentheses, so it's just x to the 1/2 power. So in this case, our 5 would be pulled out, and then it would be times the square root of x. And that would be it there. Again, the difference between number 3 is everything here is in parentheses, so that means everything is going to the 1/2 power. So that would basically, again, 1/2 power we know is the square root of 19ab. Okay, if we look at number 4 here, square root of 12. Now we're bouncing back from radicals into exponent form. So it's just the opposite. Here, there's nothing there, so we know it's a 2. So that'd be like writing it 12 to the 1/2 power. Over here, we've got the square root of 18b. So now everything 18b, so we're going to put 18b in parentheses to the 1/2 power. And finally, over here, number 3, we've got a cubed root. Be careful there, it's a cubed root. So we've got a 3rd root of 37h. So 37h is going to go in parentheses, And now instead of the 1/2 power, it's going to be the 1/3 power because it's a cubed root right here and not a square root. Okay, so that's pretty simple stuff there. Okay, let's do some of these where it says convert between the radical and rational exponent and then evaluate. So here they do want us to evaluate. So we're going to get an answer at the end. And I'm not going to make you evaluate if it's a irrational number or something crazy. It'll be a nice even number for you to break down. So let's look at this first one here. The cube root of 125. So we could write that 125 to what? Well, it would be to the 1/3 power, right? Because this root is 3, so that's going to be the denominator of your fraction. So it'll be 125 to the 1/3 power. Okay? And so what does that mean? What does the cube root of 125 mean? Basically what we're looking for is we got to have 3 numbers that when you multiply them out, the same number by itself 3 times equals 125. You can use your calculator right here. That might punch it in if you know how to do that. If not, you can just kind of guess and check and say 5 times 5 times 5 is 125. So our answer here would be 5. So this says evaluate. You have to evaluate it. All right, next one, the cube root of 64. So very similar to that one. We're going to skip that one. You can come back to it. How about this one up here, 27 to the 1/3 power? So again, now we know this is the cubed root of 27. Okay, and now we're trying to find basically a number that 3 times, well, number multiplied by itself 3 times would equal 27. So what times what times what equals 27? It has to be the same number. In that case, it would be 3. 3 times 3 times 3. So our answer here is 3. Okay? And that about does it. We got some tricky ones here with the 4th roots and 1/4, so we should just know how to rewrite those. Same thing here with the 2/3. That'll give you a little practice problems there. So I think I want you to practice. I know we're going to need some practice on these. It's okay. Let's give some chance. Use that table that we did in the beginning to help you out the best you can. The lesson summary here is what's the trickiest thing about fraction exponents? What do you think the trickiest thing is for you? And then we're going to have to write this rational expression right as a rational expression. So we're going to take this, and we should have an answer that has a base number and then to a power up here based on what you have there for our practice problem. Okay, so bring your practice problem, bring your questions, and we'll get after it tomorrow.